Hello folks, this is the video tutorial for assignment number 2 for people in lab section 53. Okay, there are two problems that are given, but you only need to submit problem number 2. Okay, problem number 2 is over here. So we have an object like that, and the details of the dimensions are given here. The top of this hook, think about it as a hook, is clamped, and the bottom, think about it as bottom face, is pushed down or pulled down by the amount 0.01 inch. Now notice that this was an old test problem. So look that it says, first of all, use the most appropriate element. Right here. Use the most appropriate element to solve the problem. You should not solve this problem with solid elements. In other words, don't go and try to make something like that and then mesh it with CATIA with solid elements and then solve the problem. You're going to lose a lot of marks on that because we have discussed this thing over and over and over, and we will doing it in the next few weeks, that you have to look at the problem and see what is the best element that you can, what is the most efficient element that you can use to solve this problem, to solve a problem. Okay, uh, this is a beam problem. Okay, now okay, so we're gonna draw, and then it says, look, it says not only use the most appropriate element, use symmetry to reduce the problem as much as possible. If you're going to use beam elements for this, there is no symmetry involved. If you were supposed to use, you were left alone and let to use allowed to use the solid elements, then there is one plane of symmetry, and that's just cutting this S in half on both sides. Don't do it, please, because as I said, if you use solid elements, you're going to lose marks. A lot of marks. Okay, now if you do it, however, you didn't see it, you did it, make sure you cut it then, because otherwise not only you're going to lose marks for using the wrong elements, but you also lose marks because you didn't see the symmetry, you didn't put surface slider, etc. Do not solve this problem with solid element. You are not expected to solve this problem with solid element. You must have used beam elements. Okay, that's what this thing is saying. Incomplete reduced model will. Okay, now, so I'll do problem number 2 for you, and there are two ways of doing these beam problems. One is using a sketch. Draw this thing in a sketch, join it, and proceed. And I'm going to do that first time. And then I come back and draw this thing in space as a wireframe and join it and proceed. Okay, good. So let's go ahead and get down to business. We go here, start a part file, okay, and I'm going to immediately save it. File, save management, save as, desktop, new folder. I'm going to call it homework 2 lab 53. Okay, so everything is going to go in here. Where is that? Homework, yeah, lab 53. And I'm going to give it a name. So the name is your student ID number 1, 2, 3, 4, 5, 6, 7, 8, 9. Your last name, Timoshenko. An identifier, so I'll call it S clamp. How about that? S clamp, S hook. How about that? S hook. Using sketch. And then there's going to be another one, which I'm going to be using wireframe. Okay. All right. Remember, you cannot just give any name that you want, and at the end go then using the Microsoft way try to rename it. You know, in Word file, you go and once you save it, you go and say right click, rename it as whatever you want. You can do that. Cannot do with CATIA files because it will lose track. Analysis, for example, will not know that you decided to change the name of the part. They will not know that. You have to do this in this file save management. Otherwise, you're on your own. Okay. So on a convenient plane, on that vertical plane, I will sketch that S. So there are different ways. Do it any way you want. You got to give me an S. Basically, that's what you have to do. So let me do it like this. I'm going to do it like that. You do it any way you want. Okay. So let me start here. I start there, and I go there. This is half. Oops, the other way. This is half of the S. Let's do another one. Another circle. And we're going to clean it up in a minute. Okay. Something like that. And like so. Good. Let's dimension these things. These are, according to the problem description, the diameter of each of these loops is 4 inches. So let's go and uh, make this thing 2. This is the radius. It's going to be 2. And do the same thing with the other one. 2. And exit. And this is it. Do not forget to join. Join, join. Click on it. You select the sketch. You say OK. It is now joined. Now you apply properties to it. Let's choose the default properties of what is that? Steel. Okay, so apply material, metal, default properties of steel. Say OK, and you're good. So your part is made. Let's go to. Let's now go to generative structure analysis. CATIA does not see a solid object. This is basically a curve. Okay, so it will not try to measure it with anything because there is no solid element, solid object. You have to do that. There is the beam measure. It's right there. You see this? Right there. Okay, beam mesh. You select that. It turns yellow. If you had not joined, this would not have happened. If you had not joined that sketch, this would not have happened. uh, Linear beam elements. It looks like this one, although it's there. The parabolic one, I don't know, may not be working because I couldn't, I did pick it, but it didn't work. Let me try it. Let me try it. How about that? Well, okay. You know what? It's okay. At some point, if it gives us error message saying something we cannot do, we come back and change this. Okay. Right now, it's parabolic. Okay. Now, this 0.3 means that break it up into elements which are roughly 0.3 inches. So there's going to be probably 5 or 6 over here, 5 or 6 over there. Let me keep it the way it is. I'll keep it the way it is. Okay. So let's check our mesh. So put the cursor there, right click, oops, put the cursor there, right click mesh visualization. Notice that you go in there. So here is element, I don't know, here is element, what is that? Looks like this is element. Oh, notice that because I use parabolic, there's element 65 and the nodes numbers are 3, 24, 22, and 45. There is element 66 and the nodes number are 45, 23, and 46. Look, uh, if you ask me, should I use parabolic or linear? If you're not told anything, do whatever you want. We don't care. All right, so this is fine. Deactivate the mesh and now go and assign the mesh, the section property, 1D property, 1D property, 1D property. You select that. Notice that the right material was picked, but this cross section is not correct. So I'm going to change this thing to cylindrical beam, click on the wrench, and put the radius of that cross section. And according to the problem description, the radius of the cross section, the diameter is 1, the radius is 0.5. Say okay. Notice that you can close because for a circular cross section, you don't need an orientation point. But if this was not circular, He won't let you close unless you select an orientation point that properly positions the orientation of the cross section. Not here though. Say okay. Before we go any further, let's save our analysis. File, save management, analysis, save as. Okay. The name, I'm going to use exactly the same thing. Your ID number 123456789 dash your Timoshenko Timoshenko. What is it called? What do you call this thing? S hook. S hook. Yeah. S hook dash using sketch. Using sketch and analysis one. That's fine. Say okay. There is no planar symmetry. Okay. So you clamp the top. We're told that the top is clamped. The bottom is pulled down, which means first you make it 0, pulled down by the amount 0, and then we can change it by the amount that's given. So enforced displacement on that restraint, the magnitude is pulled down by 0.01, negative 0.01. Say okay, save everything, and run it. Oh, see that? This is what I was talking about. Computing possible, 3D node beam element is not supported by affinity solver. That's a disaster. If it's not supported, why are you putting it there? So let's go here and change this. Let's go here and change it to linear. This is crazy. Okay, good. Save it now and run it. It could be for some specific application. It may be. It may run. I mean, I honestly don't know why they have it there. In the old days, I remember we could still use it, but anyway, so it looks like at least on my computer, you cannot use 2D elements. Okay, done. It worked. Look at the deformation. There we are. Put the view in the front, right there. Okay, and animate. See that? Because this was not a planar symmetry, therefore it can go through it. There's no problem. Okay. You want to look at the deflections? There we are. There we are. There we are, average ISO. Let me say that again. Unfortunately, CATIA has a terrible beam bending or beam functionalities. It does not give you any opportunity to calculate the stresses, von Mises stress at a specified point of your interest. It will not allow you to uh, to plot the von Mises stress at all. It will let you do the principal stresses, but unfortunately, the principal stress that's going to give you is axial, which is totally useless. Now, I remember there was some grumping in the class the other say, "Oh, this is useless. Then what's it good for?" No, it's not useless. It's just that if you want detailed information about your beams, you cannot get it from CATIA. Okay, as simple as that. All right. Now, suppose you want to know how much force is needed to pull this thing down. Okay, so you put the cursor at the bottom, right there, right click, create a resultant sensor, create a reaction sensor, and select that restraint that pull this thing down. You can do it easier from the screen, or you can do the clamp, okay? Because the force on that restraint and the force on that clamp will be the same. Either way, update, and you need 530, almost 36 pounds to pull this thing down. Do not multiply this thing by 2 or anything. That's what the force that you need to pull this thing down. Okay, save it. All right, now I'm going to close this. I'm going to save my file uh, with a different name. How about that? File, save management, save as. There we are. And I'm going to call it Timoshenko using wireframe. Using wireframe. Say okay. Say okay. Now, first of all, I don't need that sketch. So I'm going to delete that sketch. Let's delete the joint here. Delete the sketch. Okay. Now I'm going to do that, create that hook with wireframe, not with a sketch. And in fact, there's more work, as simple as that. In this particular situation, there's more work. So what we're going to do, let's see what we can do in space. Where is the circle? Remember, I'm in generative shape design. Look for circle, something that allows you to make a circle. This is a line, not there. Oh, there we are, right there, right there. And let me move this thing out. Let me move this thing out so that you can see it. Click on the circle. It's going to ask you a few questions. Okay. It says there are different ways of making a circle. Which one do you want to use? For example, a center and a point. Okay. 3 points. Okay. So let's do it like this. And you can do this problem different ways. Let's say center and radius. How about that? Center and radius. Click on it. Okay. What is the center? Well, I don't have it, so let's go make it. Right click, create a point. Now remember, the radius of this hook was 2, so the center of that first circle that I want to do is going to be -2 for Z. -2. Okay. Preview is right there. All right, say okay. Then it says, okay, what is the radius? Well, the radius is 2. Okay. And then it says, what is the angle? Well, let's try 0 and 80. We don't want a full circle. Let's try 0 and 80 and then see how it looks like. We've got to be careful here. We did, oh, the support is the YZ plane right there. Now it did create it, except that it's not correct. But let's try from, based on what I see here, let's try from 90 to 270. Let's see how this one looks like. That's okay. But I wanted it to be the other way around. Okay, is that the? No, that's good. That's good. Very good. There we are. Look at all this work that I had to do to create this. It was easier to do it for this problem in a sketch. Yeah. Okay. Uh, let's do another one. Another one. Once again, center and circle. The center now is going to be -6. Create a point. -6. Okay, it's right there. The support is again the YZ plate. The angle, the radius is still 2. The angle, you got to think about it here, is going to be from maybe, how about making this thing from 270, let's try this, 270 to 360. Okay, that's fine. Two, two, okay, 360. 270 to 360 plus 90, 450. Let's see if it works. Yeah, look, it's not worth it. But if you want to do it, now remember, if your sketch is not planar, if that hook was not planar, then you have no choice but to kind of use stuff in wireframe in all likelihood. But anyway, if this was a planar, I could put in the sketch. Now, let me do the rest of the problem. It's okay. Now we're going to join. There we are. This one and that one. Join these two, you apply material to it. I think the material is already applied, so that's okay, no problem. Let's save this. And now we're going to go to generative structure analysis. You select the beam measure right there. It's going to do that. Same size element. And I hope it was linear, because we know that parabolic is going to come back with an error message later on. Let's do cross section. It's the same 1D property. So we select that joint. This was correct from the last time. We can close it because it's circular. And now we're going to save our analysis. File, save management. Do not, remember, do not use the way you rename rename Word files. You can't do it like that. You have to use file save management, or else you're on your own. Okay, so you select that. This is the old analysis. Let's give it a name. We say wireframe. Wireframe. Frame. Okay, good. And we say okay. The top is hooked, is clamped. The bottom, first you make it 0 because you can change it in that direction. And force displacement, 0.01, negative 0.01. Save it and run it. I didn't save it. Let's save it first. Run it. There you are. Done. Can we look at the result? Let me put it in the front view. Right there. Deflection. There we are. You can animate. There we are. This is the displacement. You can make it average ISO. There we are. You can animate it. Okay, fine. You want to get the load? Put the cursor on the sensors, right click, uh, create resultant sensor, reaction sensor. And for the support, select that the strain that you put in here, right there, or the clamp. Update. And there is your roughly 500. I think it was the same number. I'm not sure. It was roughly the same number. Good. Save it. Done with this. Done with that. Now we're going to go to the first problem. Okay. So it's a circular arc like this. You're given the dimension, and you're going to solve this thing. See, this radius is 30, much bigger than the thickness and things like that. Therefore, the beam is the most appropriate element. Do not model this thing with solid elements unless you're not given any indications that you have to use the most appropriate element. But here it says the curved beam. Okay, so use beam elements anyway. So let's go make this thing. So the radius is, what is that, 30 inches. Okay. So let's go ahead here, start with the part file. Okay, save it, file, save management, save as. In this folder, let me move this thing here. I'm going to use this name, but I will change the S hook to how about circular arc, half circle. How about half a circle? How about that? Half circle. And I have a choice of using sketch or using wireframe. Of course, I'm going to be using sketch. Easier. You can see that. Half a circle. You know, maybe over here I should have said problem 1 at the end. Problem 1. This is so that you can see homework. Okay, how about homework 2? Problem 1. Okay. We don't expect you to do all of these, just that on the test, a particular problem, your user ID, your name, your it says problem one, okay, problem one, and then for the next one is going to be problem two, and for the next one is going to be problem three. That's how we expect you to do, okay? Save it, and let's make it. On that vertical plane, I will sketch half a circle like this, right there. Let's give it a dimension, 30 inches. It's going to be huge. Fit it. It'll come back right there. Exit. Do not forget to join it. This join is in wireframe in generative shape design, okay? So join it. You can find it in part design. You select that, select it, make sure it's selected, sketch one selected. Now you apply material. I'm going to use default properties of steel. Say okay. Now, because the cross section is square, it's not circle, I need an orientation point. And if you say, well, how did you, can I do that? Do I just guess these things? The problems that we are doing are very simple. Look at what I'm going to do. I'm going to create, somebody asked me about this question in the lecture, and I gave the answer. And if you want to know more, or if you want to know what I said, or what the question was, or how did I do it, please ask in the lab, office hour, etc., and I'll do it for you, no problem. So let me make a point. That orientation point cannot be on this curve, cannot be on the continuation of the curve. Continuation of the curve means if this thing goes down here, it's continuation. The reason is that CATIA, what it does, it projects, it creates a normal from that point to that curve, okay? From that point to that curve. If you put it on the curve, there is no normal. Okay, so let me do something which is off this plane, for example. How about x of, I don't know, x of 6? Is that what it is? Can't see this. Okay, I want to be able to see this thing. Yeah, it's okay. Okay, fine. It didn't have to, let me put it this way. Here, I didn't even have to, I could have used 0, okay? So a point that is not on that curve or continuation of it, okay? Right there, this is easier to see. I could have done 6, but 6 was going to go further to the right and I couldn't see it. That's okay. Now, this is going to be used as the identification, as the orientation point, and hopefully it's going to work. So, save this. All right. Now we're going to go to generative structure analysis. We're going to mesh it with beam elements. That's going to be a lot of elements, remember, because the thickness I put 0.3, the radius was 30. That's okay. Beam elements are so efficient that it really doesn't matter. Okay. Now you can see your mesh if you want. I'm not going to do that, but you can. Go to the property, select the support. Material is correctly selected. We don't want it to be a tubular beam. We want it to be a rectangular beam. And the dimensions is going to be 1 and 1. 1 and 1. Now, the orientation, if you zoom in, first of all, you see that it did make a cross section there, but it's kind of slanted. Orientation point will allow you to straighten this up. Just look at the way it was before, and now we're going to here. You know what? I'm going to leave this thing like that and select my point from the tree. How about that? So that you can see what happens when I select that point as my orientation point. This point right there. Watch this red stuff. It turned it. Because what happens now is that this guy is going to go in that orientation all the way around. It's not slanted. Okay. Let's go and save our analysis, save management. There's the analysis, save as. Okay, this was the S1. I'm going to use this. I'm going to use the yeah, the sketch. I use the sketch. I'm not going to call it a sketch. Remember, I called this thing to be the, what did I call this thing? Half a circle, something like that. What was it? Half circle using sketch. Okay. I just moved this thing out so that I could see the part name is up there. Okay. So half circle, half circle using sketch, and then at the end I came back and added a few more things. I said that homework 2, problem 1, etc. Homework 2, problem 1, because once again, on the test, there's going to be 3-4 problems. Each problem, for a part, you have your ID number, your last name, it says problem 1, and then your part, whatever it is. If you want, add more identifier. And then for the analysis, ID number, your last name, problem 1, any identifiers, analysis, and then you're going to save it like that. Okay? Good. This end is clamped. Oh, the reason why can I not, where am I here? I did this, I have my mesh. Okay. Something is wrong here because I cannot find. Oh, yeah. Let me double click on this. Hang in there. See, there's something bad happened here, and I think I know what the issue was. Okay, when I entered this, I think I accidentally, instead of selecting the static case, the default static, accidentally I probably close that. Okay, so I can fix this, and I'm going to show you how to fix it. But what I will do, I will close this and go back to my part and come back. Okay, here's the way you notice that you cannot access any of these loads and restraints, and something I did inadvertently, I basically killed that static job. So you say insert, look, insert static case. You see, you don't see it here. You don't see it here. When I do that, then these things light up. But I'm not going to do it like this. I close that. Back to my part here. So I'm going to get in there again. Generative structure analysis, static, good, very good. And let's mesh it, good. Let us apply section properties, 1D property on this, okay. And rectangular, these are all correct, okay. And for orientation point, I select this point, all right. You see, now I have these things because when I did it a few minutes ago, I think I probably forgot to, I said cancel or something like that. So anyway, clamp down here. You want to push this thing to the left. What is the actual problem? It says push it to the left by, oh, apply a concentrated force, okay? It says apply a concentrated force. So I just apply a force of 300 pounds. So a force there in the direction y, 300, actually minus y, because look at your coordinate system. Get rid of this. There we are. And okay, see? Looks like that, just like your homework drawing, just like that, okay? And then save it. Now, I have to save this file, save management, and save the analysis, save as. And let me see now. So I'm gonna select there. Timoshenko circle. Okay, good. Yeah, that'll do it. Because I already had this thing there. I saved it, okay? That's why I'm going to rewrite it now. I'm going to overwrite that. I don't have to create another one. I already had this thing saved there, and then I killed it, okay? So that's why I can easily use this name. It's the same thing, right? Timoshenko half circle using sketch. Homework 2, problem 1. It's going to overwrite that, which is fine. I have no problem. I don't need it. I don't need the old one. This is it. Run it. And look at the deformation. There we are. Average ISO, there we are, from view from the front, okay. Notice that it did move, and it moves, and it moves up also, okay. Because of there's no symmetry in this problem. There's no symmetry either. No symmetry in this problem. Now, if you want to exaggerate these, you can make this thing maybe maybe 0.1. Did I change that? Okay, maybe 1. There, I exaggerated. Okay, save it. And this is your homework number 2. Now, for the other lab, 54, your friends in the other lab section, that many of them are fourth year students, you probably know them, the problems are different. So you want more problems? Look at their problems. Because I keep getting emails from people saying that, well, how, what else do we have to do in order to become good at this? Well, look at other people's homework. Try to do those. All right, folks, good luck.